So this time we're going to show the quantity z varying in x and y. Here's a small change in z, which is made out of a small change in x and a small change in y. There's the change in x, there's the change in y. There's the corresponding change in z as x and y change by the amounts shown. So let's work out an expression for delta z. Well, here we've got the gradient of the change in the x direction and the corresponding change in z due to the change in x. And as hopefully is familiar now, that's going to be approximated by the rate of change in the x direction multiplied by the change in the x direction. We can do exactly the same thing in the y direction. So there's a rate of change in the y direction, and when we multiply that by the change in y, we get the change in z due to the change in y. What's the total change in z? Well, it's the two things added together. So there's the change in z due to the change in x, and there's the change in z due to the change in y. And just like we saw before, if we shrink the changes in x and y down to 0, then we define a differential in z, which is the corresponding change due to the infinitesimal changes in x and y.